So where we're at right now, time-wise, is December 21st, 2017. That's what we're looking at on this image. And you can see Australia going by. Um, December 21st was the December solstice. Now, I'm recording this on December 26th, but fortunately, you can go back in blueturn.earth and pull up other days on the calendar that it has interpolations of, and see these interpolated rotations of the Earth. Again, it's not actually a live stream image of the Earth being taken. It's not. There's no video being sent from this angle. It's a photograph taken about once every 2 hours. And what blueturn.earth has done is to interpolate those photographs to make sort of the appearance of a continuous rotation rather than snapping in 2 hour increments. Because there's so little change during two hours at this scale, the effect is really pretty close to the same. Now, you can notice, like over on the left-hand edge right now, if you look carefully, there's a little bit of one image fading into the other. And that's where that's going to show up most is way out on the edges. The clouds are almost identical between any two of these photographs. And again, if you look carefully, you might see a little bit of one piece of cloud fading out as another piece of cloud fades in, or possibly some apparent duplication, or sort of almost like a cross-eyed image between what looks like two tiny little identical clouds, and the reason being because the interpolation maybe didn't line them up absolutely perfectly, but overall, you should get a pretty good idea of what it looks like to watch the Earth rotate, except for one little thing. This is not the speed that the Earth actually rotates. Now, you've probably heard flat earthers say they don't believe the Earth spins because, it would throw people off into outer space or something, if outer space really existed, which a lot of them think it doesn't, because, of course, they can't imagine that gravity, which they also think doesn't exist, or a lot of them think doesn't exist, could hold a person down on the Earth while it's spinning around. So how much faster than this do you suppose the Earth actually does rotate? If you think it does rotate faster than this, the answer is it doesn't. This is actually 300 times the actual rotation speed of the Earth. 300 times. In other words, for every 1 second of this interpolated animation, 5 minutes of time went by on the Earth. On the Earth as seen in that image. That's quite a bit faster than the actual rotation speed. Now, you might notice that it's really hard to see far up north on this globe, and you might wonder why. Well, that's because being at the December solstice, this is the point where the northern hemisphere is tilted the most it will be all year away from the sun. And the southern hemisphere is tilted the most it will be all year toward the sun. Now, it's actually on the day after the solstice right now, but the image is pretty much the same. And if you look carefully in the southern hemisphere, I'm pretty sure you can see all of Antarctica there right now. That's that's quite a large continent there. As you can see, it's actually larger than Australia, and the whole thing is lit, all of it, at once, because the southern hemisphere is tilted that much toward the sun. Now, there might be some times as it turns around there where you'll see a little of Antarctica uh, dip off the edge and not be quite on the sunlit side. And that's when that part of Antarctica gets nighttime. But during this time of the year, most of Antarctica doesn't get any nighttime at all. And likewise, in the solstice in June, whether before this one or after this one, um, the northern hemisphere will be tilted at its maximum toward the sun. Now, that's not because the Earth is wobbling and the tilt, wobbles from south to north. It's because as the Earth orbits around the sun, in one position where it is now, the southern hemisphere is facing the sun more than the northern hemisphere, because that's the angle of the tilt. Half a year later or half a year before, at that same tilt, the Earth would be on the other side of the sun, which leaves that same tilt causing the northern hemisphere to face the sun more than the southern hemisphere. Now, again, it's still pretty close down the equator, but that's where the lines of the tropics come in. That at one solstice, the sun is basically straight in line with one tropic, and at the other solstice, the sun is basically in line with the other tropic. Now, there's South America going by again, and if you look carefully up on the upper left edge of the of South America, you should be able to see Central America, and connected to that, you can see Mexico, and the Gulf of Mexico is rather obvious in this particular image. And up farther north than that, mostly cloud covered in this particular image, is the rest of North America. Now, way up at the far north edge, you might notice it's still in nighttime, even though daytime is going by. In other words, it's still dark. It's night 24 hours a day at the North Pole, or near the North Pole, at this time of year.